The best place to start when we're talking about Java classes is, of course, objects. An object is an instance of a class, and it's meant to represent a real world entity. We're going to talk about the term state and how it relates to the attributes, and then behavior and how that relates to methods. So, object and instance are actually synonyms. An object is an instance of the class, meaning it's a copy of the class. An instance is a concrete occurrence of a class, also known as an object. So, instance, object, they're really just synonyms. That's what we call instance methods, right? Because they're relating back to an object. So you can think of it as an object method, right? That's what an instance. So for example, if you wanted to create an army of zombies in your program, you'd create a zombie class. And then each zombie would be an instance of the zombie class. And you can create as many instances as you want, or as many copies of those zombies. And each copy could be similar, right? They might be, identical. They might be clones, or you might make some zombies different, right? You can make them unique depending on how you create that object and how you modify it. We'll learn how to do that in the next slides. So, what is a class? Well, a class is an object's blueprint. It's a user-defined data type. Because remember, there are primitives, and then everything that's not a primitive is defined by a class. So those are non-primitive. So classes define non-primitive data types. But when you peel back the layers of any class, you're always going to end up with the primitive data types. These are the building blocks of Java, right? Everything is built off the primitives. So again, doesn't matter how many classes you have, how complicated the program is. If you continue to peel back all those classes, that goes for the Java standard classes as well. You're gonna find just primitives. So each class in Java usually is usually placed in its own .java file. Let me fix that typo. So that those files usually go inside the source folder. If you wanted to organize things into packages, you can have additional folders, right? Because a package is a group of classes. You can add additional categories or like organizations, right? Structures. But for our class, we're just going to throw all the classes in the source folder. And each class is going to have its own .java file. You don't have to do this. You could have multiple classes in one .java file. There are certain reasons you might do that, but we're not going to cover that in this class. So key components of a class. So these are the members of a class, the things we use to build a class. So there's the fields or attributes, constructors. So constructors are used to build the objects. The attributes describe the object. So that's why this goes first, right? We'll talk about state in a sec. Methods, that's the behavior of the object. And then access modifiers is who do we give access to actually use those attributes or methods. So when you code your own class, you define what data and behaviors the object will have based on the needs of your program. So the attributes are variables that hold data about the object. So an object really is a group of variables. Those variables are being grouped together and they're being followed together through the life cycle of the object. When you just have variables declared, in a program outside of a class, outside of an object, so just regular variables, they're not really grouped together, right? They live on their own. But when you define those as attributes of a class, those are special variables, then those variables are basically grouped together. They belong to the object. So in a car selling Java program, what kind of data would you need to track on each car in a car class? So just a little question to think about. We'll answer that on the next slide. And then methods. So methods are the actions the object can perform. So if this is like, how we describe what the object looks like or information about the object, well, what the actions or the behavior, the things that the object can actually do, that would be defined through the methods. So in a role-playing video game, what kind of behavior would you need to define for an enemy character? So in object-oriented programming, every object has two main characteristics, which actually relate back to attributes and methods. So the attributes are actually describing the state of the object. That's the current set of values stored in an object's attributes. That's what state refers to. This is a really big vocab word in programming. One that I wish when I was learning about programming that was talked about more. State we talked about. We talk about stateful and stateless when we get into advanced programming. So talking about state this early on is really important. So state represents the current data or condition of the object. So for example, car object might have the brand attribute equal to Honda, the model equal to Civic, and then the color equal to red. So the state of that object is a red Honda Civic. That's the current state. Maybe it might change right later on if we paint it, for example. And then behavior. So actions that an object can perform. So it describes what the object can do. So going back to role-playing video game, well, an enemy character object might have an attack behavior to be able to attack your player, right? To do what most enemies do in video games.